Now next topic is the parallel plate capacitor. Here we have to find the capacitance of a parallel plate capacitor. Now in parallel plate capacitor we have to take two plane parallel conducting plates as shown in the figure, and these two plates are with large area and the separation between these two plates, that is equal to suppose small d, and here we have to take the medium between two plates, that is vacuum. Now here plate number 1 is possessing charge plus q, and on plate number 2 there is charge minus q. Clear? Now here surface charge density of plate 1, that is plus sigma, and for plate number 2 that is minus sigma. Now first of all here we have to find the electric field in different regions. Now see here, we know this thing, electric field due to charged plane, that we studied in chapter number 1. So that is sigma upon 2 epsilon 0. In chapter number 1 we derived this thing. So for positive charge, the electric field that is going out from the charge, and for negative charge it is from infinity to charge. So here if we think about the electric field of positively charged plane plate, then its electric field on left hand side, that is starting from the plate up to infinity with value sigma upon 2 epsilon 0. Similarly on right hand side also from plate up to infinity sigma upon 2 epsilon 0. Then for negatively charged plate, the electric field that is from infinity to plate. So on left hand side from infinity to plate with magnitude everywhere sigma upon 2 epsilon 0. Similarly on right hand side from infinity to plate, that is the direction, with magnitude sigma upon 2 epsilon 0. Now let's think about the net electric field in all these different regions. So see, suppose we think about the electric field in region number 1. So here due to positive plate, the electric field that is sigma upon 2 epsilon 0. Due to negative plate it is also sigma upon 2 epsilon 0. But see the directions of these two, that is opposite to each other. So net field that is sigma upon 2 epsilon 0 minus sigma upon 2 epsilon 0, and that is equal to 0. Similarly on right hand side, the field due to positively charged plate, that is sigma upon 2 epsilon 0, right, going to infinity, and due to negatively charged plate from infinity to the plate, magnitude again sigma upon 2 epsilon 0. So here both the fields are equal in magnitude but opposite in direction. So again in this region number 2, the net electric field will be equal to 0. But see, here there is the different case between these two plates. Now see here, due to positive plate, the electric field between two plates, that is sigma upon 2 epsilon 0. Due to negative plate also it is sigma upon 2 epsilon 0. But both the fields are in the same direction. So net field will be sigma upon 2 epsilon 0 plus sigma upon 2 epsilon 0. That is sigma upon epsilon 0. Now sigma, that is surface charge density, area of the plate is A, charge on the capacitor, that is Q. So we can replace sigma, that is Q by A. Now potential difference between these two plates of the capacitor, that is V equal to electric field into the separation between these two plates. So E into D. So substitute the value of E. So E, that is Q upon epsilon 0 A. Clear? Now, as per definition of the capacitance of capacitor, we take capacitance C, that is Q by V. So here, if we take Q by V from this equation, then capacitance will be epsilon 0 A by D. So here we can see this thing, capacitance depends on the dimensions of the capacitor. It depends on the area of the plates, the separation between the plates. Clear? Now see here, in previous topic we discussed this thing, the capacitance of capacitor is measured in the unit farad. Farad, that is tremendous large unit. That is tremendous large unit. Now how large is this one? Let's try to understand this thing. Suppose we want to make a capacitor which capacitance equal to 1 farad. So for that, we consider the separation between two plates, that is 1 millimeter. So if by keeping the separation between two plates 1 millimeter, if we want to prepare a capacitor having capacitance equal to 1 farad, then what should be the area of the plates? Let's calculate. So here C, that is epsilon 0 A by D, so A, that is CD upon epsilon 0. C 1 farad, D 1 millimeter, so 10 raised to minus 3 meter, epsilon 0 8.85 into 10 raised to minus 12. If we solve this one, then answer will be nearly equal to 10 raised to 8 meter square. So we can write this one as 10 raised to 4 meter into 10 raised to 4 meter. Suppose we think about the square plate. Okay. So length and breadth of the plate, that will be 10 raised to 4 meter to 10 raised to 4 meter. Means 10 kilometer by 10 kilometer. Means if we take two conducting plates with length and breadth equal to 10 kilometer, and then after, if these two plates are separated by 1 millimeter, then we will get a capacitor of capacitance 1 farad. Now imagine a conducting plate having dimension 10 kilometer by 10 kilometer. Then the capacity of the capacitor, that can be obtained 1 farad. So this farad, that is tremendous large unit. Okay, so it is too big unit. Clear to all of you?